Alright, so this video is going to be about our static electricity. Right? So if you haven't done so, make sure to watch this video and then go back to week 3 and complete your Flipgrid assignment. But you have to be able to explain what's going on in the experiments. So what you're doing is you're doing anything with friction, you're pulling off excess electrons. So people did great about that. So then those excess electrons would be attracted back to whatever you rub them on. Right? Now what you need to do though is if you talk about what if you take it over to something that is neutral. Because if you notice here, if we look here, there's no, there's no charge on the wall, but I can get the balloon to stick to the wall. So let's talk about why that is. Well, watch what happens with all these electrons. So as these electrons come over, you should be able to see that the other electrons, right here where they're on my mouse, those electrons are pushed, so only those electrons can move. So your excess electrons push the electrons in the wall away, and then the protons are there left to attract. And so then you should be able to answer some questions about what's going on with the charges and explain that in your video. So that's how you can attract or repel a neutral object that we have there. Because again, the charge difference, the wall is neutral and I'm still able to attract. Over here, I'm able to attract something that has lost electrons and is now positive as well. So now what we need to do is get into current. You should have read this in your reading guide, what current is you should know and what voltage is. So we're going to talk about that. So again, right, let's look here. So if we get a buildup of electrons, you'll notice those electrons do not want to be near each other. Those charges want to repel and they push away from each other. Right? Now essentially though, they're not pushing hard enough to move. So this is called static electricity because the electricity isn't moving. But electric current is when you have those electrons moving. Now, if those electrons are pushed hard enough, because like charges, all these negatives repel, that's when you'll have a flow of electrons. So here, still don't have enough. There. They all pushed away, and you saw that flow of electrons, which is electricity. So, but you have to have enough voltage to be able to push them that we have there. Take a look at this. This thing is called a Van der Graaf generator. What it does is it builds electrons up onto here, and then let's see what happens. So you saw all of those little objects go flying. So essentially what happens is we built up all those electrons. The ball here is a negative charge, and then those little pieces of paper get negative charges. So they push away from each other. And again, that push, an electrical force is called a voltage. And a voltage causes movements of electrons, which is current. And so that's what we'll as we go to some other things. And so I really think that this diagram does a great job of showing us what's happening. Voltage is what is pushing the electrons, and the current is the amps, how fast they have to flow through there. Ohms is the resistance that has to stop it, but voltage, there has to be something pushing those. And so that's what's happening. Is all this buildup essentially pushes, and so they go this direction. So a battery with more voltage is going to push harder. So here, as you can see, if I have a lot of voltage right here, all these are built up together, and so they're going to push really hard. If I had low voltage, right, so if my battery didn't have very much voltage, as you can see, this voltage is going down, there's not as much electrons that are built up. So if I had 0 voltage, Okay, and you also saw that would be whoops, let's see if I go right here in the middle. 0 voltage is when it's even on both sides. So there's no reason to go from one side to the other. Right? So as you can see, if these guys are here looking for a date, it's even on either side, so there's no reason to even move. But if those are all pushed to one side, they're much more willing to try to move, and I like to joke about find a date there. Let's look at some more little circuit things here. So here you can see as you build a battery, it pushes the electrons out, right? And so no matter what I do, I keep trying to push things out here, and the electrons keep pushing away because I have voltage in this battery, so they are going to push. Now the problem is, in this one, they can't push hard enough to make this gap. So that's what a light switch does, is as you close this switch, now the electrons are able to be pushed out, and that's what we have is called a current, or an ammeter measures that movement of those electrons, and they're being pushed by the voltage. And so what I can do here is if I push harder, you can see they flow faster. And if I slow down, they flow less. So again, as I push harder, I have more volts. My amps are going to increase. But now we have to look at this ohms, or what is the resistance going on. So resistance is opposing the amps, or opposing the flow of electrons here. So let's take a look at some of these here. And so I think this is a good example to see. Oops, that's not the one I wanted. Here you go. So again, voltage is how hard I'm pushing. Resistance is what's trying to stop this. So if I have less resistance, that means there's less molecules that are kind of smashed in here for those electrons to hit as they're going through. So as resistance goes down, current goes up. I'm able to flow more if I have less resistance. So again, this top guy, ohm, if he's pulling less, the amp man, or the current, will be able to go more. And again, with voltage pushing that. So again, you can always go back to that diagram, pause this, and be able to think about through some of these problems. Here's another one, right? So this kind of lets you know the flow. So if I reduce my resistance, so there's less particles to hit, I'm able to flow faster. If I increase my resistance, it's really hard for these to travel, the current flows less. Then the other option, though, is to push harder. Volts is how hard you push. So I can push really hard, and it's still going to make it through either way. Then you can start to do some other interesting things with a circuit. So what you can do is you can actually take a light bulb and you can reduce its resistance down, right? And so what happens if you have no resistance, then you can think about what's going to happen. And this should flow extremely fast if we were looking at this here. Let's see if we can get it to go. Whoops, come on. Don't know if we have any voltage. We have 0 volts. So now if I push, here you can see what's happening. If there's no resistance, things are just going to go crazy. So you have to have some resistance. So as I get some resistance, the light bulb essentially slows things down. If there's nothing to slow you down, then it's going to go crazy, and the current's going to go so fast you can actually catch something on fire. And so that's why you have to be careful. If you had a battery like this and you just put a piece of wire over the top, that's what would happen. You have to have resistance. So if I was just to set this here, it would start to get hot. Okay? If I was doing that. That's typically why you want things that have resistance, and we have those in our house to slow things down. But if you ever have a short, that's what would happen as you just saw there.